What considerations should be made when working on houses from a different time period? Well, first of all, you should consider the age of the building and look up the building on Cardu's listed building register to confirm its status. Identify the listing grade, is it grade 1 or grade 2? This affects the level of restrictions. Then you've got to apply for listed building consent, submit a planning application. So if the renovations include structural changes, this additional planning application might be necessary. It's not always necessary. Other considerations are, as an electrician, if you're registered under a competent person scheme such as the NIC, EIC or NAPIT, you can self-certify your work, but after completing the job you'll notify your scheme, which will inform the local building authority department on your behalf. If you're not registered, you must notify the local authority's building control department before starting any notifiable work. This typically involves submitting a building notice or full planning application along with a fee for inspection. Once the work is completed, the inspector may visit the site for approval. If the work meets regulations, you receive a completion certificate from the building control, or if you're part of a scheme, a certificate of compliance. In either case, you provide your client with the necessary certificate, keeping all records for future reference. This should have been included in your handover or details if you were doing that type of work. Examples of notifiable work are installing new circuits, a new consumer unit, work in bathrooms or near water sources, outdoor electrical installations like garden offices and hot tubs. A condition report helps assess its overall state before you do any work. It highlights any urgent repairs, potential issues and maintenance needs. If a building has suffered damage due to a natural disaster, fire or other incidents, a condition report helps determine the extent of the repairs needed. An EICR should be done before changing a consumer unit, as a new consumer unit would only be as safe as the wiring it connects to, and you're changing the characteristics of the supply sometimes by getting rid of old fuses, and now you're putting circuit breakers in, so all the characteristics change. It's also compliance with the regs, and if there's any underlying faults, damaged cables, poor earthing installation, a new consumer unit could create a serious risk as well. So you always do an EICR before making any changes to a house. And I've heard a couple of people saying that they've just done a change, and then they've found the faults afterwards. But if you did the EICR first, you'd know, and maybe you wouldn't take that job on. Solid wall construction typically didn't have a damp-proof course because it was a traditional building method used before widespread knowledge of damp prevention. So these walls were made of materials like brick or stone, which are more porous and can absorb moisture from the ground. Instead of a DPC, older buildings relied on lime plaster, which is great because it was breathable. Lime plaster allowed moisture to move through the walls, known as breathing, helping to prevent the buildup of trapped moisture. So the natural properties of lime also made it less likely to promote mold growth. However, the introduction of cement plaster in the 20th century altered everything. Cement plaster is less breathable than lime, meaning it can trap moisture inside the walls. So when moisture is trapped, it can lead to damp problems like rising damp or condensation, as the walls will have no way to release the moisture. This is why older houses with cement render may experience issues with moisture buildup and decay, as the walls can't breathe. In older homes, an open fire ventilated the walls. The heat from fire would draw air up the chimney and in turn encourage air circulation through the house, and it helped to ventilate moisture and maintain a dry environment. So in contrast, modern houses are built much more tightly sealed to improve energy efficiency, reducing air leaks and heat loss. But this can lead to poor ventilation, trapping moisture inside and creating conditions ripe for condensation and mold growth. So as a result, modern homes often require dehumidifiers or mechanical ventilation systems like heat recovery ventilation. So we'll be all over that if you want to talk to him about that. Manage moisture levels and maintain a comfortable, healthy indoor environment. So with these systems, excessive moisture can cause problems with air quality and building fabric over time. Rising damp refers to the upward movement of water from the ground into the walls and foundations of a building. So this occurs through porous materials such as the bricks or stone, which allows moisture to travel upwards through the capillary action. It is commonly seen in older buildings without effective damp-proof courses. The water can weaken the building materials over time, cause the mortar to degrade and lead to the collapse of bricks or stone, particularly in the older buildings. Paint, wallpaper and plastic can be damaged by the rising damp, causing peeling or staining, and the electrical back boxes will rust, so anything you install is going to be so when you've got a short lifespan if the walls are wet. And it'll also lead to insulation resistance shorts, so it's costly repairs for the client, and prolonged exposure to damp conditions can contribute to respiratory problems. You might see in a lot of houses that there's black mold on the walls, and if it's low to the ground, that's because of rising damp. Then you will get black mold in other places because of poor ventilation, like baths and showers. Water always finds the coldest spot on the wall, condenses, and that's where you get mold then, but that's a different issue. So wattle and daub is a technique for building houses for, I think they were medieval houses. So wattle is a framework made of interwoven wooden strips and sticks or branches, willow and hazel, which provide the structural support. And then the daub was a mixture of clay, mud, straw. Sometimes they'd use horsehair, lime as well. And they put that on the building. That was like the render back in the day. And if you see old Tudor houses, this was a technique they used then. I know you're wondering why I'm talking about that. It's because he brought it up. It's in Unit 301, and it's one of the bits of knowledge that you need to have, old building techniques, because you're doing a building services engineering qualification, and wattle and daub was one of the techniques that was brought up. So there's different types of cable you'll come across when you're doing work in older houses. They've got different hazards. Vulcanized Indian rubber just breaks down when it's touched or moved. So it's going to be a rewire if you come across that sort of cable generally. So you can add to it and try not to disturb it and damage it, but it's on its way out. It hasn't got a lot of years left in it. You've got old cloth wiring, which was used until the 1960s, that contains asbestos. Leave it alone. You'd have to report it to your supervisor if you come across it. The 1960s and 1970s, they used aluminium wiring. It had oxidization issues leading to poor connections and overheating with the expansion and contraction, and it caused loose connections, and then there were fires caused. So they tend not to use aluminium cores in house because it just heats up too much and loosens in the connections. So that's why we use copper now. It's still used for overhead lines and things that are lugged, but it's not great for screw terminations. Old 60s wiring, so there was a batch of cable from 1965 to around about the early 1970s that was used, and the insulation reacts with copper and it turns to a green liquid, and then you've got an insulation resistance shorts. And if you find it, there is a way to treat it and slow it down, but eventually it's going to need a rewire for that as well. It's just a consideration for things that you might come across if you're in someone's house. It might be having faults because of this type of cable. And there's also pilk cable, which is paper insulated, lead covered cable, and it's got lead in it, bitumen, and sometimes asbestos for heat treatment, heat proofing. And when this cable gets warm, the bitumen can melt and it'll drip all over the fuses of the equipment that's in when I've come across it. Other considerations you should make when working on older houses are the walls were made with black mortar, so lime and coal dust. They can weaken with age and lead to structural instability. Basically, there's not a lot holding the brickwork up because the mortar just turns to a dust in the end, and it's not really doing a lot. Ceilings were made with lath and plaster. I've spoken to a couple of apprentices who said they're still doing work on houses with lath and plaster. It's probably a nightmare putting spotlights in lath and plaster ceilings. I've only ever ripped it down, never done work on it. It's absolutely stinking. There'll be all black mortar up your noses for weeks, and it is prone to cracking and sagging. So while those covered with Artex may contain asbestos as well, so when you're doing any drilling, first, if you suspect it's asbestos, don't work on it. But if you do work on anything and you're drilling overhead, always wear a mask. So in your projects, hopefully any drilling you've done, you're wearing a mask. And asbestos can cause a serious health risk if you do disturb it. Similarly, old wallpaper and paint can contain arsenic or lead. So Victorian houses, they used to use all sorts of chemicals to get the colouring on the wallpaper, and all now contain arsenic. So that's toxic if you inhale or ingest it. Outdated electrical wiring and plumbing systems may also increase the risk of fire or water damage. So those are other things. If you're messing around with the pipe work, you might have a bad day. So you've got to take precautions before when you're doing your reno work. Subsidence of houses is a critical issue due to its potential to cause structural damage and instability. It occurs when the ground beneath a building settles or collapses, often as a result of natural factors like soil composition or human activities such as mining or groundwater extraction. The results effect can include cracks in walls, ceilings and foundation, and compromise the integrity of the structure and potentially rendering of a building. So you'll see a house that's basically, if a tree is too close and the tree sucks up all the water from the ground, it can loosen the soil and weaken the soil, and then the house will slowly sink into that spot where the water was and where the roots are. Also, a lot of coal tips and stuff around here, so that sort of affects it as well. There's a lot of steep valleys, so there's a lot of soil movement. Sash windows. He hasn't brought it up, but they're in older houses. They're single glazed, so they got poor energy efficiency. They can have a lot of drafts. They can, if they were made of wood, you can get plastic ones, PVC ones now, but the wooden ones, they'd swell and then they'd stick and rattle and rot. And inside the cavity, there is a lead weight that matches the exact weight of the window. So when you push the window up, the window holds still. Over time, the cords inside the cavity can rot. So and then those windows don't work very well, so you have to replace them. I suppose it can have an effect on your electrical work then if you were doing any electrical work near that. Also with the water, you can get condensation and mold on those single glazed windows. Dry rot's a concern for electricians because it weakens the wooden structures that support the electrical installation. So you got the joists, beams, walls where wiring, sockets and fuse boxes are connected, and the timber can deteriorate, so electrical components might become unstable or detached. And there's a proper risk of exposed wires, short circuits and fires. So dry rot thrives in damp environments. Then it can exacerbate electrical hazards like moisture-related faults, so insulation resistance issues and stuff again, and corrosion of metal components, so your back boxes and screws, whatever, are going to rot. So the wood should be treated or replaced before continuing your work, and these are the considerations you want to make when working on older houses. Cavity walls, they prevent rainwater from penetrating the inner wall, and they reduce the issues of damp or mold. So originally these cavities were left empty, but from the 1970s onwards, insulation like foam or mineral or polystyrene beads were used to improve energy efficiency. So some cases, poorly installed cavity wall insulation can cause moisture retention and lead to internal damp problems. The whole point of the cavity is to stop the water tracking across, so an air gap stops that happening. The only option it's got then is to cross the wall ties, and they're designed in a way with a drip. The water will just fall down the cavity and be directed outwards through a weep vent and things like that. So there's different types of cavity wall insulation. You've got partial fill insulation, and there's full fill insulation, and the full fill can cause bridging of the cavity. Again, the rock wool will become saturated with water or moisture, and then that's the water's route through into the inner skin. Again, you can have spray foam insulation or these polystyrene beads. They will also bridge the cavity, and a lot of people are having that sort of insulation sucked out, so they're considerations that you want to make. Damp-proof course was introduced in the late 19th century to prevent damp rising up through the walls. Typically it was installed at the base of the walls to stop moisture seeping up from the ground, and the benefits of DPC include preserving the structural integrity of the building by preventing brick and mortar deterioration, reducing the risk of mold and mildew, and improving indoor air quality. For electricians, the presence of a damp-proof course is crucial to consider because rising damp can affect electrical wiring outlets, the back boxes again, and any metal-clad sockets, steel conduit, and sockets located near the floor. Moisture can cause corrosion of the metal components, increase the risk of electrical faults, and potentially create dangerous conditions for short circuits or electrical fires. So you've got to ensure that proper DPC is in place and helps prevent these risks and maintains the safety of the electrical installation. Wooden step ladders. They were not designed to support the weight of modern electricians who carry a lot of heavy tools and equipment. So the treads on old ladders were prone to damage and could not handle the load that today's type of work demands. Modern ladders were built with weight capacities and they're more durable. So the materials like fiberglass or aluminium, which are safer and more robust. Imperial and metric. Most tools used by electricians in the past were designed with imperial measurements, so they don't align with today's standard metric system. If you don't understand that, that's inches used to be used, and now we're using millimeters and centimeters. So the mismatch can lead to confusion and inaccuracies when measuring or cutting materials. Modern tools are designed with metric measurements in mind, so ensuring consistency and accuracy in electrical work. Insulation and ergonomics. So older tools were uninsulated, posing a significant safety risk when working with live electrical systems. Modern tools are insulated and protect against electric shock, and older tools were not designed with ergonomics in mind, so they might be a pain in your hand or whatever type of tool it is, and it'll make them uncomfortable for long use and cause a lot of strain. So today's tools are engineered for comfort and safety, reducing the risk of injury. Plumb bobs. In the past, electricians would use a plumb bob to get vertical alignment. It was effective, and the method was time consuming and less precise than modern spirit levels, so your accuracy is out. But they offer, the modern spirit levels offer quicker and more accurate readings. So the spirit levels become a standard tools, making the job faster and more efficient. If you don't know what a plumb bob is, it's just a weight on a string. And it can be placed inside an old spirit level as well. Wind-up mega tester. So in the past, insulation resistance tester were often wind up. So they lack batteries. They were used to check the integrity of the insulation. The older models were bulky and manual, and they required more effort to use, and they were less accurate with the readings. Today's digital testers are far more efficient, and they offer more instant and accurate readings without the need for winding or any effort. You've got roll plugs, and you've got your hammer and chisel. So roll plugs were made out of wood, and electricians had to rely on a hammer and chisel to do chases for wiring. And if you can imagine chasing an old stone wall, how time consuming that would have been. And it was messy and inefficient works. So today's wall plugs are made of plastic or metal, and they're more accurate. If you could use tools from a different time period to do work, how would this have changed the way you approached your tasks?